Okay, this video is for the derivation of the trigonometric formulae 4 and 5, and you'll see why. So formula 4 is cos of a minus b is equal to cos a cos b and sin a sin b. So the first thing we do is we have a unit circle with a triangle drawn inside. We let P be the point cos a sin a and Q be the point cos b sin b. Then we just pull it out just to have a look at the triangle itself. Now in this diagram, the angles that are marked, angle A is going from the x-axis all the way over to this terminal side. Angle B is going from the x-axis to this terminal side. So that's how this angle in here is angle A, the entire one, minus the little bit of angle B that was actually outside of the triangle. So using the cosine rule, PQ squared, so this is this line here, so the one opposite the angle in question. This one here is equal to this side squared plus this side squared minus 2 times this side by this side, cos A of the angle, cos of the angle A minus B. And we tidy that up, so 1 squared is 1, 1 squared is 1, and 2 times 1 is just 2. So we then have, when we add the two ones together, the length of PQ squared is equal to 2 minus 2 cos A minus B. And that's our first formula that we will need to bank later. If we then look at the distance between these 2 points and use the distance formula, we have cos A minus cos B all to be squared plus sin A minus sin B all to be squared, coming from these points here, the square root of that. The first thing we do is square both sides to remove the square root sign. Then we multiply out the brackets. So just take your time with this one. Square the first, twice the product, okay, and square the second. Square the first, twice the product, and square the last. If we then take our cos squared A and put it with our sin squared A, and our cos squared B and put it with our sin squared B, and then we just take our minus 2 cos A cos B and minus 2 sin A sin B, we just write them down as is, you'll notice that this is the same as our formula 1. So now we can write that as being 1 plus 1 and then the rest of the line. Add them together and we end up that the length of PQ squared is equal to 2 minus 2 cos A cos B minus 2 sin A sin B, and this is our second formula that we bank. These two formulas are equal to each other because both formulas were equal to the size of PQ, or the length of PQ, all to be squared. So we can now write the two of them equivalent to each other. The first thing we do is we can remove the 2 on either side. If you bring that over, it'll become minus 2. 2 minus 2 is nothing. And we get left with this. So the next thing we're going to do is divide absolutely everything by minus 2. And we end up with cos of A minus B is equal to cos A cos B plus sin A sin B. Then for formula 5, it's cos A plus B equals cos A cos B minus sin A sin B. Now all we do here is we use the exact same proof, but instead of having B, we put in minus B. So I'll just take you through to the last part where the two formulas are equal to each other. And by writing in the minus B in brackets here, rather than multiplying it out, then it is our A minus the minus B. So it still ties in with exactly what we had beforehand. So two sides are equal to each other. We subtract the 2 from each side. We divide everything by minus 2. And then we just multiply out our brackets. So the 2 minuses become a plus, which is fine. And what happens here is, and here, this has been divided by minus 2, so it's now plus cos A, cos B. But the minus B here doesn't have any effect because when you've cos of a minus angle or a negative angle, it's just cos B. That's given in your maths tables. Up here, this would also be plus sine A, sine B. But because of the fact that when you have sine of a negative angle, it becomes minus sine B, that's how you have the minus here.